In this lesson, we are going to learn about the common types of chemical reactions. And when we know the type of chemical reaction, of course, we are going to be able to determine the product that will produce from the reactants. So for this lesson, we are going to focus, if I were to give you a chemical reaction, can you determine the type of each chemical reaction? The first common types of chemical reaction is combustion. We recognize combustion very easily because combustion is basically any substance, usually a hydrocarbon. So a hydrocarbon, think of the term hydrocarbon. Of course, going to be dealing with hydrogen and carbon, but in some cases they have oxygen as well. This will produce, if it has an oxygen, more likely it's going to be an alcohol. So anything usually hydrocarbon, and this hydrocarbon will burn by reacting with oxygen gas. So we're talking about pure oxygen gas. And of course we have the oxygen gas in the atmosphere or the air that we breathe in. We have a very generic chemical equation to represent combustion. Again, carbon, hydrogen, and sometimes oxygen react with oxygen, and they will always produce this two substance or two product, carbon dioxide, which is CO2, and water, and a lot of heat. Okay, so that is combustion. An example of combustion would be methane gas that we have at home react with oxygen, and it will produce water and a lot of heat or energy. Okay, and this is the methane gas that we use to cook at home. And the next type of reaction is decomposition. Think of the term decompose. When a substance is decomposed, it breaks down into little pieces so that other organisms can absorb in. In this case, decomposition again is a compound. Think of the term A, so that's a singular form. So a compound, that's mean one compound breaks down into two or more substances. Okay, so now in most cases, a decomposition reaction requires some kind of external heat source. That means we apply some kind of energy to get the reaction started. And of course, this AB is one compound broken down to A and B. A specific example of decomposition is hydrogen peroxide, H2O2, and that is decomposed into water and oxygen gas. So that's decomposition. One compound break down into two or more substances. Then we have the opposite of decomposition, which is putting things back together. In this case, we call synthesis. When we synthesize something, we combine the part together to make a larger substance. So synthesis, basically, when we synthesize something, we combine the little pieces together and make a larger substance. And in a synthesis reaction, we have atoms and or molecules combine to make a new compound. Notice this is a singular form, so we are making one new compound. Like in this case, a substance A and substance B combine together to make a new compound, one new product. So keep that in mind. An example would be calcium plus chlorine gas. We would make calcium chloride. Notice how we have two reactants and one product. So that's synthesis. Then we get to single replacement. Think of the word single. Singles mean one, and think of the word replace. So something, especially one thing, is replacing another thing. Okay? Or to be specific, one element is replacing another element in a compound to form a new compound. And the way it works is this. In order for an element to displace or replace another element in a compound, that element must be more reactive, okay, than the element in the compound. So we are going to look at this more carefully when we look at the reactivity series. But for now, keep that in mind. The more reactive the element it is more likely it's gonna go in and kick out the other element in that compound. There are two types of single replacement. One is that one negative ions replace another negative ions. For example, in this case, we talk about chlorine. In chlorine gas, we would have Cl minus, and that's the ions that make chlorine gas. And in here, we have potassium and iodine. We know potassium is a metal, so that's plus. And iodine is actually I-di, and that's your negative ions. So this chlorine gas can come in and kick that iodine out. And that iodine is going to be lonely in this place. And of course, here you have KCl, because the KCl come in and kick out the iodine. And what happened to the iodine that got kicked out? Of course, in most cases, it would bond with itself, and we have I2. So again, notice the pattern. We have a negative ion come in, kick out another negative ions, and make a totally new compound. Or the other type of single replacement is that a positive or one positive ions replace another positive ions in a compound. So in this case, we have calcium, right? To make calcium, we need calcium ions, or calcium ions. And that's a positive charge. And here we have hydrogen chloride. In this case, H is, we don't know it's plus or minus, but we know Cl is minus 1. So we know this must be a positive. So in this case, the calcium can come in and kick out the hydrogen, and the hydrogen can be out, wander in a different place. So what we have here, of course, calcium, this calcium come in here. Now it's going to bond into chlorine or chloride. So we have calcium chloride, and the hydrogen that gets kicked out is going to bond with itself and form a gas, hydrogen. And that's the way it works. So that is single replacement. A positive ions replace another positive ion. And the last one is very easy. It's called a double replacement. And the way it works is that you either have a negative ions, okay, or a positive ions of two ionic compounds. So we're talking about negative or positive ion of two ionic compounds. And those ions, either positive or negative, they switch places to form two new compounds. For instance, if I say A is positive, B is negative, C is positive, and D is negative, what happened? I either switch the positive with the positive or the negative with the negative. In this case, what do we have? We have D's right here is negative. It's switching with B. So what we have here is A and D, okay, and C and B, because the B and the D switches, because they're both negative. Let's look at a real example. Here I have sodium carbonate. We know sodium is a metal, so it has Na+. And carbonate is CO3, 2-, okay? And calcium chloride, we know the calcium is the plus, and the chloride is minus. And if you like to switch with the positive ions or the negative ion, it doesn't really matter. But in most cases, it is more likely to switch with a positive ion. But again, it doesn't really matter. So in this case, we have specifically, notice how we have sodium, it becomes calcium. So it must switch the positive ions. So the calcium go over here, which is we have calcium carbonate, and the sodium go over here, we have sodium chloride. See, that is really easy, isn't it? And one of the most important information that we need to realize that in reality, reaction happen very slowly, especially in all living things. In the cells, in microorganisms, they happen very slowly. So what happens is that there's a beautiful thing called catalyst, okay? And a catalyst helps speed up a chemical reaction, but is never consumed by the reaction. So a catalyst will always be there speeding up the chemical reaction as long as there are reactant and product involved. One of the most common and the most important catalysts in life is enzyme. Enzyme is the biological catalyst that make all living things possible. And then if you are driving a fancy car, platinum, a very expensive metal, this is used as a catalyst. Now let's try some example problem where we have to identify the type of chemical reaction. Okay, so first of all, what I have here is a single compound and is broken down into two or more substances. And what do we call that when something breaking down into little pieces? That process is called decomposing. So it's decomposition. Okay, so this is decomposition. And then here we have two substance, and all of a sudden we have one substance or one compound. When we have two things combined together, we synthesize it, right, into something larger, and of course we call that synthesis. So that is synthesis. Isn't that easy? And here I have CHO and oxygen, and I look at my product, I have carbon dioxide and water, and right away I know there has to be combustion, because combustion is the only one that produces carbon dioxide and water, starting from the hydrocarbon with oxygen. So isn't that easy, combustion? Then we have lead, Fe, or iron sulfate, and all of a sudden become lead sulfate and Fe, or iron. Notice how this is lead, but this is Fe, so the positive charge right there of lead now come in, so it's 2 plus actually, so come in and kick out the iron, okay? And that's how we have that lead sulfate, and the iron's by itself because it just got kicked out. Oh, too bad. So we call this a single replacement, specifically a positive ions replace another positive ion. So this is called single replacement, okay? Then we have silver nitrate plus copper. All of a sudden we have copper nitrate and silver. So basically that copper come in and kick out. If this copper is positive, okay, it's gonna kick out, well in this case 2 plus, it's gonna kick out the positive, which is silver here. And right away we have copper nitrate, and the silver's got kicked out, so it's all lonely over there. So single replacement again. Then here we have HBr plus aluminum hydroxide equal to water and aluminum bromide. So notice how this is positive, this is negative, this is positive, this is negative. Notice how the place of Br got switched around, isn't it? Br is with the H, now all of a sudden Br with L. So you can say that the negative is switched, the negative ions between two compounds is switched. And when we have a negative ions or positive ions of two different compounds that switch places, we call it what? Double. See, double replacement. So that would be a double replacement. Then here we have one compound, and all of a sudden it's broken down into two compounds. Of course, when something broken down or breaks down is the process of decomposing. In this case, decomposition. And then here we have another compound. In this case, we have F2, which is fluorine. We have with sodium chloride, and all of a sudden, this come in here, and we have NaF, sodium fluoride. So what does that tell you? The F, or the fluorine ion, which is negative, come in and kick out that negative. So chlorine is by itself out here, and which is gonna form each other to form a gas. So in this case, we have one negative ion kick out another negative ion. This is called a single replacement. Specifically a negative ion kicking out another negative ion. And that is all we have to do when it comes to identify the type of chemical reaction.